Equation of continuity. Equation of continuity. We can draw a diagram of a pipe having variable cross section. XY is a pipe having variable cross section. So this is a pipe or tube of variable cross section. Variable cross section. A pipe or tube of variable cross section. The end X has the area of cross section A1 and the other end Y has the area of cross section A2. Ideal liquid flows into the tube or pipe with a velocity V1. V1 is the velocity with which an ideal liquid flows into the pipe, and V2 is the velocity with which liquid flows away from the tube from the end Y. So we can denote the flow of liquid in this way. At the end X of the pipe, this is what different layers of liquid, and from the end Y again liquid emerges with the velocity V2. Here liquid means ideal liquid which flows through this pipe of variable cross section. This is the liquid flow through this pipe of variable cross section. We can denote the direction of liquid flow from the end Y. Liquid flow we can denote, and liquid flow occurs towards right from the end Y. Equation of continuity will be A1 V1 equal to A2 V2. That means the product of area cross section and velocity of flow of liquid will be constant. A1 V1 equal A2 V2. This is the equation of continuity. This is the equation of continuity. A1 V1 equal A2 V2. The equation of continuity states that the product of area of cross section of any portion of a pipe or tube, and the velocity of an ideal liquid, or fluid under bracket non-viscous, incompressible, which cannot withstand any shearing stress in streamline flow is constant. Hence, the equation of continuity states that the product of area of cross section of any portion of pipe or tube and the velocity of ideal liquid or fluid, non-viscous incompressible liquid which cannot withstand any shearing stress in streamline flow is constant. Therefore, area of cross section of any portion of the pipe into velocity of liquid flow equal constant. Therefore, A dot V equal constant. A is the area of cross section of any portion of the pipe. V is the velocity of liquid flow. A dot V equal constant, which is known as equation of continuity. And let V1 be the velocity with which an ideal liquid an ideal liquid flows into a pipe XY of variable cross section through the end X of area of cross section A1. Similarly, the flows that is emerges from the pipe XY through the end Y of area of cross section A2 with a velocity V2. According to equation of continuity, according to equation of continuity, A1 V1 is equal to A2 V2. That means the product of area of cross section and velocity of liquid flow remains constant for the ends X and Y of the pipe of variable cross section. A1 V1 equal A2 V2, which is the equation of continuity. And this is applicable for streamline flow of an ideal liquid through a pipe of variable cross section. A1 V1, and here V1 is the velocity with which liquid flows into the pipe or liquid enters into the pipe. A1 is the area of cross section of the end X of the pipe. V2 is the velocity with which liquid emerges from the pipe through the end Y, and A2 is the area of cross section of the pipe at the end Y. In this case, A1 V1 is equal to A2 V2. Additional information: V by T is the rate of flow of liquid with which it enters into the pipe at the end Y. V by T at the end X, V by T is the rate of flow of liquid with which it enters into the pipe. Again, let V be the volume of liquid. V be the volume of liquid which flows into the pipe XY through the end X in time T. V be the volume of liquid which flows into the pipe X through the end X in time T. Therefore, rate of flow of liquid through the end X is V by T, volume by time, which is equal to A1 V1, product of area of cross section and velocity of liquid flow. So V by T, it can be proved that V by T equal A1 V1, that is the rate of flow of liquid at the end X of the pipe. Similarly, at the other end Y, V by T is equal to A1 V1, which is the rate of flow of liquid at the end X of the pipe XY. Again, at the end Y, V by T can be written as A2 V2. That is again rate of flow of liquid at the end Y of the pipe XY. Both the rate of flow of liquid, and in this case this rate of flow of liquid will be same rates of flow of liquid. V by T is the rate with which liquid enters into the pipe, and in this case rate of flow of liquid V by T is equal to A1 V1 at the end X, and at the end Y, V by T is the rate of flow of liquid, and in this case V by T is equal A2 V2, and both the rates of flow of liquid will be same. In this case, V by T equal A1 V1 will be equal to V by T equal A2 V2. Both the rates of flow of liquid will be same. Another additional information is the equation of continuity. The equation of continuity under bracket A dot V equal constant bracket close represents The conservation of mass of liquid. The conservation of mass of liquid in case of moving fluids. The equation of continuity represents the conservation of mass in case of moving fluids. Another additional information. Here we can denote the direction of liquid flows, direction of flow of liquid through the pipe XY having variable cross section, and there is no loss of liquid. That means mass of liquid is conserved. Mass of liquid remains conserved. Additional information according to equation of continuity, A dot V equal constant. That is V proportional 1 by A. It means that V proportional 1 by A. It means that larger the area of cross section of any portion of the pipe, larger the area of cross section. Larger is the area of cross section, comma, smaller will be the velocity of liquid flow through the pipe. It means that larger is the area of cross section, comma, smaller will be the velocity of liquid, and vice versa. According to the diagram, as A1 greater than A2, V1 will be less than V2. In the diagram, area of cross section A1 is greater than A2. That's why V1 will be less than V2, because larger is the area of cross section, smaller will be the velocity of liquid flow. Additional information: in river, deep water, the deep water runs slow and less deep water runs fast. Deep water runs slow and less deep water runs fast. We can draw a diagram of river, flow of water through a river. This is different layers of liquid or water, different layers of water of a river. Less deep water runs with velocity V1. This is what less deep water level, which flows with a velocity V1, and deep water level flows towards right with the velocity V2. This is a layer of deep water. In this case, V1 greater than V2. That means less deep water runs fast, less deep water flows fast, and deep water flows slow.